My dear viewers, welcome to my YouTube channel. Today we shall discuss about a nameplate details of a circuit breaker. So, no more delay, let's start. Rated voltage. The rated voltage of a circuit breaker is the highest system voltage beyond rated nominal voltage at which the circuit breaker is intended to perform its duty. The rated voltage is expressed in kilovolt RMS and referred to phase voltage for three-phase circuit. Normal current. The normal current of a circuit breaker is RMS value of the current which the circuit breaker can carry continuously and with temperature rise of various parts within specific limits. Frequency. 50 Hz, the standard frequency for a 3-pole circuit breaker in India, is the frequency of power system. The characteristics like normal current breaking capacity etc. are based on the rated frequency. The temperature rise of current carrying parts and neighboring metal parts is influenced by eddy current heating, which is further influenced by the frequency. Arc extension during departing of contacts of circuit breaker. Frequency plays an important role as number of current zeros per second depends on system frequency. Power frequency withstand voltage. The circuit breakers connected in power system are subjected to power frequency over voltages due to phase to earth fault, regulations, Ferranti effect, higher tap selection, etc. The circuit breaker should be capable of withstanding the power frequency over voltages which are likely to occur. These capabilities are verified by conducting power frequency voltage withstand test. For 400 kV circuit breaker, IEC defines 610 kV RMS voltage value between open contacts and 520 kV RMS with earth of the circuit breaker. Lightning impulse withstand voltage in kV peak. The circuit breaker is subjected to impulse over voltage due to lightning and switching surge. Lightning impulse withstand voltage in kV peak is that voltage which a circuit breaker is capable to withstand. The manufacturer tests this capability of that circuit breaker. Next, switching surge withstand voltage in kV peak. The circuit breaker connected in a power system is often subjected to impulse over voltage due to switching surge. Switching surge are generally occur above 245 kV voltage level due to energization of long lines or switching of high capacity transformer. This capability is also tested by the manufacturers. Fast pole to clear factor. In three-phase AC circuit breaker, R extinction in 3 poles is not simultaneous as current in 3 poles are mutually 120 degree apart. Arc extension may occur first at any pole or phase in the order of RYB, YBR, BRY and depends on at what instant the fault has occurred. Suppose a line-to-line fault occurred between phase V and phase Y and VRY the voltage between phase R and Y at that faulty condition. Now faulty section is disconnected, then VRN voltage between R phase and neutral at healthy section. Hence the power frequency recovery voltage of the pole in which the arc gets extinguished first is 1.2 to 1.5 times of the phase voltage. In the first pole, where the arc extinguished, power frequency recovery voltage of the phase divided by phase voltage after normalcy is equal to 1.5 or 1.3. So, the first pole to clear factor is equal to RMS value of voltage between healthy phase and faulty phase divided by RMS value of phase to neutral voltage with fault removed. That is VRY by VRN. Short time withstand current in kiloamps. The rated short time withstand current of a HV circuit breaker is the effective value of the current that the circuit breaker can withstand when the circuit breaker is in the closed position during the rated short circuit current flowing within shortest specific time expressed in kiloampere. Duration of short circuit. The rated duration of short circuit is the time in second during a circuit breaker should be able to carry short circuit current equal to its rated breaking current. Short circuit breaking current. It is the highest RMS value of short circuit current which a circuit breaker is capable of breaking under specified condition and is expressed in kiloampere RMS. Rated short circuit breaking current, sometimes also expressed as symmetrical breaking current and asymmetrical breaking current. When a RL circuit is closed with AC source, the resulting current consists of two components, the DC component and the AC component. The AC component is superimposed on DC component. The magnitude of DC component depends upon the voltage at the instant of closing of circuit breaker. When circuit breaker is closed at the voltage 0, the DC component is maximum, and if the circuit breaker is closed at voltage maximum, the DC component is 0. Here in the picture, we see the short circuit current has a certain value at the instant of contact separation E dash. The breaking current refers to the value of current at this instant. Symmetrical breaking current is the RMS value of AC component of short circuit current at the instant of contact separation. Asymmetrical breaking current is the RMS value of the combined sum of the DC and AC component of short circuit current at the instant of contact separation. Short circuit making current. If the circuit breaker is closed on an existing fault, fault current may increase to the maximum value at the peak of first current loop. The circuit breaker should be able to close without hesitation as contacts touch. The circuit breaker should be able to withstand the high current and the mechanical forces caused by the current. The current is called as short circuit making current in kiloamps. It is generally 2.5 times of rated short circuit breaking current. Making current is equal to 2.5 into breaking current. Out of phase breaking current in kiloamps RMS. The out of phase breaking current is assigned to a circuit breaker to be used for synchronizing. If the circuit breaker is being used for synchronizing to two different power, it may happen during synchronization the circuit breaker has to open, and current generated during this condition is called out of phase breaking current. The rated out of phase current that the circuit breaker shall be capable of breaking under prescribed conditions of power frequency recovery voltage and transient recovery voltage. The rated out of phase breaking current is 0.25 times of rated short circuit breaking current. Out of phase breaking current is equal to 0.25 into rated short circuit breaking current. Next, rated line charging breaking current. When long high voltage lines are charged either on load or no load, one type of current is generated due to the charging is known as line charging current. The maximum or highest amount of this current which a circuit breaker is capable of breaking is known as line charging breaking current, and it is expressed in kiloampere. As per IEC, for 420 kV circuit breaker, the said charging current is 600 ampere. Operating sequence. The operating sequence denotes the sequence of opening and closing operations of the circuit breaker under auto reclosing duty. We know an auto recloser closes the respective circuit breaker automatically after its opening due to fault occurrence at that circuit where the auto recloser is installed. Circuit breaker is made to be capable for this operation according to auto recloser's commands. The circuit breaker should be able to perform the operating sequence as per one of the two alternatives. O. Opening operation, C. Closing operation, CO. Closing followed by opening. Small t 0.3 second, capital T 3 minute, T dashed 50 second. Occurrence of fault. O. Opening due to fault 0.3 second interval. Then C. Auto closing. If fault clear, circuit breaker remain closed. If not, CO. Closing is followed by opening. Interval of 3 minute. Closing. If not stood OK, then C is followed by opening O. Now SF6 gas pressure at 20 degrees centigrade. The circuit breaker is filled by SF6 gas of pressure 6.5 bar at 20 degrees centigrade. Circuit breakers are also specified in different unit of pressure like hectopascal, megapascal, bar, kgf per centimeter square, etc. by the manufacturers. Pressure changes in accordance with temperature of the site of installation. Next, total mass of SF6 gas, mass of circuit breaker, reference standard, year of manufacturing, customers, NOA number are not needed to be expressed here. Next, classification. M2 and C2. M stands for Mechanical Endurance Class. According to international standards, IEC, the M class is subdivided into two, M1 and M2. M1 class circuit breaker will perform 2000 no load operation without any major maintenance. M2 class circuit breaker will perform 10,000 no load operation without any major maintenance. So, it is extended mechanical endurance class. So, the M2 class is better than M1 class. Now, C stands for capacitive charging breaking current of a circuit breaker. It is also subdivided into two groups, C1 and C2. The C1 type indicates it has low permeability of restriking during capacitive charging breaking current. But C2 class indicates it has a very low permeability of restriking during breaking of such current. So, the C2 class is more effective. Other parameters are not discussed here. So, all these are the parameters of a standard EHV circuit breaker. Please subscribe, share and like. Also do comments. Thank you for watching this video.